Alright, so here we have a problem that says determine equations of the tangents to the curve y equals 2x squared plus 3 that passes the point 2, 3. Okay, so in the last video we discussed what a tangent was. It's a straight line that passes through through a specific point on a curve exactly once. Like it doesn't intersect the curve more than once or less. So if we take the example of x squared plus 1, which would look something like that. I'm not doing it exactly with the markings. We could see that there are actually two tangents that pass through a specific point. So if, let's say, we wanted to see the things that pass through this point here, which could be, I don't know, 2, 1, we know that 2, 1 is not on the curve x squared plus 1, because when we substitute 2 into x, that gives us 2 squared, which is 4, plus 1, which is 5. So actually the point's the point is a little bit above, 4 units above exactly where it's on the curve. So we can say that this is an external point because it does not lie on the curve. It's asking us to find the tangents that pass through that point but connect with the curve. Well, we can see that one would be this one over here. Another would be that one over there. And those are really the only two that work. However, we cannot just find the equation of the tangent with a diagram like this. We actually have to use some algebra, especially when the questions get a lot tougher. So let's go through this one first. So 2x squared plus 3 that passes through the point 2, 3. Well, if we think about it, let's imagine a point on the curve y equals 2x squared plus 3. That would be a 2a squared plus 3. You might be wondering, whoa, where did a come from? Well, let's say a, or well, rather, let's just say x is equal to a. So we basically substitute for every x that comes in the form a. And this makes sense because if we substitute a specific value in x, it would generate a y value using this equation. So I think it's safe to say that this is a point on the curve. And they've given us another point that's on the tangent, which is 2, 3. You might be wondering, well, this isn't on the curve. Why is it important? Well, it's because we're trying to find the equation of the tangent, not the equation of the curve, which is already given to us. And to do so, since the tangent in this case is a straight line, we can use the tangent formula, or the gradient formula, sorry, of a tangent. The gradient formula is y1 minus y2 over x1 minus x2. And in this case, we actually have two distinct points. It's just that they have a in them. So we can try substituting in. So let's say this is our first coordinate and this is our second coordinate. So y1 would be 2a squared plus 3. So 2a squared plus 3, and then y2 is 3 here, minus 3 divided by, and then we do the same with the x values, a minus 2. Now, you might be wondering, well, how do we find out the value of a? That's actually not too bad, because when we learned in the last video about finding the equation of a tangent to a curve, we could see that when we differentiate a function, we actually got its gradient. So if we differentiate it, dy over dx of that function, we get 4x. And since x is equal to a in this instance, we had said x is equal to a. That means that our gradient is actually 4a. And we can equate this gradient to our actual gradient function over here. So 2a squared plus 3 minus 3. Well, these two cancel out, so I'll just write 2a squared over a minus 2. And now we can solve this equation. So that's equal to, we can just multiply each side by a minus 2 to give 4a squared minus 8a, which is equal to 2a squared. Which means that 2a squared is minus 8a is equal to 0. And if we factor that, that gives us 2a times a minus 4, which is equal to 0. Which means that a is equal to 0 or 4. So that gives us the value of a. And now, if we look at this part over here where we said our gradient is 4a, we can really just substitute the values of a we got in there to find the gradient of our tangent. So let's say that a is 0. Well, 4 times 0 when we substitute a in is equal to 0. So that means there's actually no gradient to this function. There's no gradient of this tangent to the function. So since our gradient is 0, so it's y equals 0x plus c. So it's just y equals c. So now we need to find c. Well, that's not too difficult, because if we see here, it's saying to the point 2, 3, and the y coordinate is 3, which means that we eventually have to end up with y equals 3. But there's nothing to substitute into x, so we don't really have to do much. The equation of the tangent is just y equals 3. But we also need to find the other tangent. So let's substitute a in as 4. So 4 times 4 is equal to 16. So it's quite a large gradient. Now we can say that y equals 16x plus c. Substitute our value of y, which is 3 in this case. So 3 is equal to, and then substitute our value of x, which is 2. So that's 16 times 2 plus c. So 3 is equal to 32 plus c. C is equal to negative 29. So the equation of the other tangent is y is equal to 16x minus 29. And you can graph it on a calculator, and you'll see that it touches at one distinct point, and the two lines intersect at 2, 3. The way we can check to see that they actually intersect is you can substitute a value of 2 in there, which gives you 32. 32 minus 29 is 3. And over here, y is anyway equal to 3. The other way you could do it, I guess, is check that any value you substitute of x, a value you substitute of x in here will generate this result. But I think if you've differentiated correctly and you factorized correctly and made a correct equation, you should be fine. So let's do one more example. All right, so here's the last problem we're going to attempt, the second problem we're going to attempt. So it says determine equations of the tangents to the curve y equals x squared plus 4x plus 1 that passes the point 1, negative 3. So the first thing we got to do is establish our two equations. So the first one is our differentiated equation. So dy over dx of this is 2x plus 4. And then our other equation establishes like the normal gradient formula because the tangents are straight lines. So we do y1 minus y2 over x1 minus x2, which is I forgot to just add, we need to say x is equal to a. So really, this would actually be 2a plus 4. Then the other one is a squared plus 4a plus 1 minus negative 3, which is plus 3 essentially, which is divided by a minus 1. So now we've got our two equations and we can just equate them. Plus 4 basically, divided by a minus 1, which is equal to 2a plus 4 times a minus 1 is equal to a squared plus 4a plus 4. Essentially, we're just solving for a at this point, which gives us 2a squared minus 2a plus 4a. So 2a squared plus 2a, and then minus 4, which is equal to a squared plus 4a plus 4. And then we can bring everything to one side, which gives us a squared minus 2a minus 8, which is equal to 0. And we factor it, which gives us a minus 4 times a plus 2, which is equal to 0. So our two values of a are 4 and negative 2. And now we can just say that we can take the gradient formula over here, 2a plus 4, and substitute a in. So 2 times 4 plus 4 gives us 12. So our first gradient is 12, and let me just split the screen. The other side, we have 2 times negative 2 plus 4, which gives us 0. So our other gradient is 0. So with the gradient which has 12 in it, we have y is equal to 12x plus c. And then if you look at the points, 1, negative 3, it has to pass through there. So we can just use that point. So negative 3 is equal to 12 plus c. c is equal to negative 15. So our first one is y equals 12x minus 15. That's equation number 1. The other equation, our gradient is 0, so we just have to look at the y value of the coordinate here, which is negative 3. So our other one is y is equal to negative 3. So that's how you solve this problem. These questions are very unlikely to pop up on the AdMath exam, but it's always good just to know because it is on the syllabus, so they could test it on us if they wanted to. It's a bit of a trickier one to understand at first, but once I wrapped my head around it, it was a lot easier to handle. I handled it using this method where you use a, because x just makes it confusing because we are using x to define coordinates. Let me know if you need any help in the comment section. I'll try and attach problems, though I actually don't think I'll be able to attach problems because they're very hard to find. But if you need any help on a problem you do encounter, let me know and I will be happy to help with it. Anyway, thanks for watching this video and see you in the next one.